ושוב תודה אלון ותודה לכולכם שבאתם ועל ההזדמנות להציג ולתרום לכם טיפה מהידע שחברת אקספלאו הבינלאומית מביאה לתעשייה בארץ. אז כמו שצוין, אנחנו חברת הנדסה בינלאומית עם 19,000 מהנדסים בכל העולם ומספקים שירותי הנדסה עם התמחות בעולם האירוספייס אנד דיפנס. דוקטור סיימון הנקוק מחברת סטירלינג דיינמיקס, היא חברת בת שלנו שיושבת באנגליה, היה אמור להגיע לפה להרצות בנושא אורבן אייר מוביליטי, הוא מוביל לתחום ה-eVTOL אצלנו בחברה, הוא לא יכול היה להגיע כמובן, אבל אנחנו נשמע את ההרצאה שלו, והרעיון הוא שהוא באמת ייתן לנו קצת מהידע שלהם בעולם בפיתוח eVTOL ואיך זה בא לידי ביטוי בזירה הבינלאומית. צריכים רק להפעיל לו את הסרטון.
Hello, shalom. My name is Simon Hancock. I'm the eVTOL Business Manager for Stirling Dynamics. I'm sorry I can't be with you today in person, but my colleague Gur is here. I hope we'll be able to meet with some of you at the event. I just wanted to start with some background and explain why I'm interested in this subject that we're going to talk about today. Gur and I work for the Expleo group. Expleo provides engineering services all around the world with currently 19,000 people in 30 countries, covering not just aerospace, but also marine, automotive, and other areas of technology. It's a truly global organization. As I said, 19,000 engineers, 30 countries, covering all sorts of great technology. Expleo can offer a wide level of program support from aerostructures to safety critical software and also advanced manufacturing support. So we're only getting to the future phases of all these new programs. And Stirling Dynamics, the area I work in, is a subsidiary of Expleo. We're a UK-based engineering company that's been supporting many different aircraft programs for over 30 years, both in military and civil, fixed wing and rotary. And we're now getting involved in supporting companies developing new types of aircraft in the advanced air mobility sector. We can provide technical services for specialist areas such as flight sciences, so the design of aircraft systems and components, supporting right through to certification. As you can see on the slide here, covering a range of the areas you work in, so from loads of neuroelastics, modeling, simulation, supporting flight trials, and the safety and certification aspects. So you can see there's a lot of crossover between what we do in the eVTOL world and what we do in unmanned systems. And with Stirling, as with Expleo, we work with all the major aerospace and defence companies right across the world, and we've been doing this for many decades. And it'd be great if we can help, so we can grow this into Israel as well. The title here mentions the evolution of passenger aircraft, looking at how things have changed. But it's only really true up to a point. If you go back to the early days of aerospace, you see a lot of similarities with today's advanced air mobility sector. There are lots of startups, although that phrase didn't really exist back in the 1910s, 1920s. Lots of different concepts of aircraft, different ideas, some more sensible than others, like these. But quite quickly we settled on something that started to look like a standard design. You look at these aircraft, say from about the 1950s, and then you look at how the design aircraft today hasn't really changed an awful lot. We got to a point about 50, 60 years ago where we sort of settled on a design and it hasn't changed. And from an aerospace engineer, coming from a traditional aerospace background, that makes our life a lot easier. We built up processes, procedures over many decades. We have a settled certification framework, both the aircraft themselves and the operating environment, and air traffic control and everything around that. But now it's all different, and that brings a lot of challenges. And you look at the new types of aircraft, eVTOL, air taxis, advanced air mobility, whatever you want to call them. These are very, very different. There are lots of different configurations. You start to see some similarities, and maybe we're going to perhaps converge on a particular type of design for different applications, but who knows? And these aircraft will be flying in urban environments, which we don't typically do these days, at much lower altitudes. But the planned production rate has only ever really been seen in automotive and consumer electronics, and a demand for much shorter timescales. As you say, there's many different approaches, and I don't think we can make these in the same way that we've made traditional aerospace in the past. So you've got new aircraft, new technology, new operating environments. All these have their own challenges, and we're facing them all at the same time. So, I mean, setting aside the issues of the infrastructure, air traffic control, and public acceptance for now, just from our perspective, looking at design and production of the aircraft, there's some real challenges ahead. If you look at the more conventional aircraft that we had a look at earlier, we've got decades of corporate knowledge, lessons learned to fall back on, aerodynamic and structural models and analysis tools, so we can compare our new design with what's gone before and get confidence in our processes and designs. Typically, if there are any useful models or tools that have been developed, these are going to sit with the major primes who've been building aircraft for a long time, and these won't be available to any new startup. So Airbus and Boeing and Gulfstream are not going to hand over their wing models and the structural models for any new startups to pick up on. And yet, look at the complexity of these aircraft. They're not in the same configuration they've been used to. In the example here, we don't even have wings on it. So we've got multiple rotors, interaction between the airflows around the rotors, and potentially from the urban environment they're operating in. And we're only now starting to see tools being developed that will allow us to model these effects. Even for the more standard elements of aircraft, such as wings, if you're a new company building your first aircraft, you don't have those existing designs to use as a starting point. You have to create all the aerodynamic and structural models and processes from scratch. And these aren't old models that you validated against wind tunnel tests and flight tests from years of experience and going through your previous programs. So a new configuration, we don't have that history in the models and the data. So we're really starting from zero. So we're integrating lots of new technologies into configurations that haven't existed before. And these are operating in different environments, all with a prime focus on safety, obviously, and trying to comply with regulations that are constantly evolving. So everything we're trying to do is new and complicated. And add to that, the timescales are way, way shorter than anything we've ever seen. And I think this is something we can learn from the expertise and experience in the drone industry, where many people have come into this from different backgrounds, different expectations on how quickly products are designed and released onto the market. Get people who've not come from an aerospace background, but maybe from consumer electronics or automotive, who are just more used to doing things more quickly and having much more efficient processes. So how do we, in eVTOL, how do we accelerate our design process? Should we be thinking more like a drone company than like Boeing or Airbus? So it's not just the designers who have all these issues. It's a tough job for the regulators too. If you look back at these images you saw earlier, you can see so many different types of aircraft with so many different operating regimes. It's difficult to come up with a simple set of rules to prove how the design is safe. But how do you do this with no previous examples or validated models to refer to? We don't even know are we following CS-23? Is this a small aircraft? Is it CS-27, like a small helicopter? Or is it something in between, some combination of all these? And the regulators aren't really in a position to dictate what rules we use because the designs are different. So they're asking designers to prove, why is my aircraft safe? And this is very difficult to do when you're a new company with a new design. We used to proceed through careful, incremental development, proving one aspect at a time, through physical testing or wind tunnel testing, but these new programs are likely to rely on virtual testing and the use of digital twins. And all this is just about the aircraft themselves. It's something common between eVTOL and drones. It's understanding how we integrate with existing air traffic control environments, how we're going to cope with multiple flying taxis and drones flying in and around our cities at low altitudes. Even if we can technically prove it safe, we have to bring the public with us and integrate into our airspace. So that's why it's great to see Israel, the National Drone Initiative, is taking a lead on this and looking at how we can turn these ideas into a reality that we can all live with. And this is such a big change. We really need our governments working in collaboration with industry. So I said, it's new aircraft, new rules. And looking at how we try and make all this happen, so these challenges of scale, we're trying to do these individual challenges, and they're tough, but trying to do it at scale is unheard of in aerospace. We're creating new AAM companies, developing drones and eVTOL aircraft. Well, all the time, the existing aircraft companies are still there. So will we have enough engineers? So the other companies are still recruiting, they're still employing their engineers. So we now have to generate a whole new generation of aerospace engineers who can solve these problems for us. So I hope and I believe that these new innovations are so interesting and exciting. We're looking at flying taxis, looking at drones and unmanned aircraft, that we should be able to inspire the next generation to join us and become aerospace engineers. But even then, when we have these engineers on board, our processes and manufacturing set up to deliver products more like automotive and consumer electronics than like aerospace. We're just not set up to produce at those rates. So we could probably learn a lot from those other industries. I mean, can we pick up automotive processes, consumer electronics processes? Well, to achieve these goals, we need to build more partnerships. So the knowledge is there, but we need to be better at working together. So the future can't be like the old aerospace, where established primes can create detailed requirements for suppliers to follow. The new primes need to look at supply chain for innovation and expertise, not just capacity. And bring your best suppliers on board earlier in the development process. So most suppliers will have worked with multiple aerospace companies or multiple programs over many, many years. And that diversity of thought can be really useful. This new relationship can't just be one way though. So for us in the supply chain, like Stirling and Expleo, we need to be prepared to challenge our customers, take more responsibility and offer innovative solutions. And this openness and trust between primes and suppliers, so you can form these partnerships, can be a bit of a culture change for some organisations. They may be used to sort of flowing information down and telling suppliers what to do. The suppliers need to be pushing up and delivering more for their customers. So to summarise this, it's an incredibly exciting time to be involved in the aerospace industry when all these new innovations are happening. But there's some tough challenges ahead to get over the line. Whether we're working in eVTOL or drones, if we're smart about how we can use the resources we have available, we can get there. So that's the end of the talk. So enjoy the rest of the event. Please visit Gur and Dana at the Expleo stand and we can carry on this conversation. Thank you and goodbye.
תודה רבה לסיימון, אני מקווה שנהנתם מההרצאה. כמו שסיימון ציין, אנחנו מביאים לשוק הישראלי את הידע ואת הניסיון שלנו במתן שירותי הנדסה בכל התחומים לעולם האירוספייס. יש לנו אלפי מהנדסים בכל העולם, עובדים עם החברות הכי גדולות בתחום האירוספייס אנד דיפנס, עם התמחות בעולם האירוספייס אנד דיפנס, ויודעים באמת לתת מענה לכל אתגר הנדסי שיכול להיות. סיימון נמצא בחברת סטירלינג דיינמיקס, חברת בת שלנו בבריסטול, יש לנו MRO בצרפת, יש לנו חברה שמתמחה במערכות עיניה בגרמניה. כל אתגר הנדסי שיש לכם היום בתעשייה, אנחנו יודעים להציע פתרון מהיר, מיידי, על בסיס המון ניסיון של עבודה עם כל חברות ה-Aerospace and Defense הכי גדולות בעולם וגם פה בארץ. מספקים שירותים לתעשייה כבר הרבה מאוד שנים, עובדים עם כמה מהחברות הכי חשובות כאן בתעשייה, ושמחים להביא לכם את הפתרונות ההנדסיים שלנו על בסיס הידע והניסיון שצברנו ב-40 השנים האחרונות עם 19,000 המהנדסים שלנו. אז אנחנו בסוף מציעים שירותים זמינים מיידית על בסיס המון ניסיון מכל מקום בעולם ובארץ. אנחנו גם חברה שהיא מרושיינת איאסה, וקבלן המשנה העיקרי להנדסה של כל היצרנים הכי גדולים, איירבאס, בואינג, המון חברות בתחום המל"טים, עובדים עם BAE Systems. אם יש איזשהו אתגר הנדסי שאתם עומדים מולו היום, שדורש פתרון מיידי, מהיר, זול, על בסיס המון ניסיון, מוזמנים לבוא לבקר אותי פה בביתן. תודה רבה לכולם.